Data teacher person. My A/B test finally finished running. The green button got more clicks than the red button on my website, so I can roll it out, right? Congratulations! We do still need to look at the p-value and statistical significance to make sure your uplift is valid. Huh? What does that mean? We want to know if the green button won because of dumb luck. So your green button got more clicks than the red button. There are two possibilities why this happened. First, the uplift could just be because of random luck, and this is a one-time thing. Second, the uplift could actually be real and repeatable if tested again. And these two probabilities add up to 100% of the situation. Rearranging this equation a bit, we get that the likelihood that the uplift is real is simply 100% minus the likelihood the uplift is due to random luck. So here on the left-hand side of the equation, the likelihood the uplift is real is what we commonly call statistical significance. On the right-hand side, the likelihood the uplift is due to random luck is simply what we call the p-value. Now let's take a closer look at how we should be using p-value and statistical significance for decision making. You probably heard of the gold standard, 95% statistical significance. You might also have heard in null hypothesis testing to set the alpha value to 5%. And 5% here is equivalent to our p-value. A 95% statistical significance, or 5% p-value, is indeed the gold standard in academia. When a graduate student wants to publish a scientific study, they want to make sure the result is reliable and repeatable. In real life, though, you don't need to hold yourself to this standard. Let's go back to our green versus red example. If we calculate statistical significance and it turns out to be 90% and the p-value is 10%, the question you need to ask yourself is, am I comfortable scaling out the green button broadly instead of the red button, given that there is a 10% chance that the green button's superior performance may just be random luck? If the answer is yes, then go ahead and call the green button your winner. If not, then go ahead and either extend your test to run for a longer period of time, or just repeat the test again. Next, let's take a look at how we calculate statistical significance. There are two types of success metrics, where the stat sig is calculated differently. Binary variables have two outcomes, either yes or no, 0 or 1. Continuous variables could be metrics like revenue, where the value can range continuously from negative infinity to positive infinity. So first, let's take a look at binary variables. I made a calculator that I'm going to put a link down below so you can copy and use. But right now, let's try it out with our green versus red button example. All we need to do is input these 4 values highlighted in yellow, and the rest will be automatically calculated. So we have 1,000 website visitors each for the green versus red button, and they each had 120 and 100 visitors who clicked on the button. And voila, there you go, you get the results. The p-value is around 7%, and the statistical significance is 92%. To generalize this calculator for all other purposes, we simply change the names of the columns and rows to test and control, and change the website visitors to number of inputs, change the number who clicked to number of positive outcomes. I've hidden a couple of rows to calculate the standard error and z-score. Basically, I used a z-test for the analysis, and I'll talk about that in a different video. Now let's take a look at continuous variables with an example. A website has 2 different algorithms for surfacing their merchandise. The A/B tested algorithm 1 versus algorithm 2. The success metric is revenue generated, and they got the following results. For continuous variables like revenue, the calculation is a bit different from that of binary variables, specifically because we'll need the standard deviation of the mean as an additional input for the calculation. So I made another calculator, and let's try it out right now. In this calculator, we need to input the fields highlighted in yellow, the number of inputs, the mean value, and the standard deviation. And voila, again, we got the results right away. So there you go. In the next video, we're going to go over how exactly I made these calculators, namely what is a t-test and how to evaluate standard error and z-scores. Thank you for watching. See you next time.